All right, today we're going to go back to the very beginning. We're talking about the origin story of generative AI. And we're going to look at the two foundational models that really kicked everything off, GANs and VAEs.
I mean, we're all swimming in this world of incredible AI right now, aren't we? You've got these amazing art generators, massive language models. But have you ever actually stopped and thought, wait a second, how did we even get here? What was that first spark that taught a machine not just to analyze information, but to actually create something new? Well, the answer really boils down to two pioneering architectures. And honestly, if you get these, you'll understand so much more about where we are today. So let's dive in with the first one, the master of what's basically an adversarial game.
Okay, first up, Generative Adversarial Networks, or as pretty much everyone calls them, GANs. And that name, adversarial, well, it's a huge clue. It tells you almost everything you need to know about how these things work.
So what exactly is a GAN? Well, Ian Goodfellow came up with this brilliant idea back in 2014, and it's a system built on pure competition. Just picture two AIs, two neural networks, locked in this constant battle of wits, this intellectual arms race where they're just constantly forcing each other to get smarter. And the best way to wrap your head around this is with an analogy that totally clicks. You've got a generator who's like a master art forger, right? Their whole goal is to create a fake so good that nobody can tell it's not the real deal. And then you have the discriminator, who's the detective, the expert with the magnifying glass, whose entire job is to sniff out the forgery. So here's how this little game plays out. The forger, the generator, starts with just a bunch of random static and creates an image. Then, the detective, the discriminator, gets a lineup of pictures, some real, some fake, including the generator's latest creation. And it has to decide, real or fake. Now, here's the magic. If the generator gets caught, it learns why it got caught and goes back to the drawing board to do better. But if the discriminator gets fooled, it learns from its mistake and becomes an even better detective. And this cycle just goes on, millions of times. So what's the end goal here? Well, eventually, the generator gets so ridiculously good at making fakes that the discriminator is just guessing. It's only right about half the time, basically a coin flip. And at that exact moment, you know you've got a generator that can create brand new, totally convincing, and super realistic images from scratch.
And this is what made GANs famous. We're talking mind-blowing photorealism. They got incredibly good at creating faces of people who literally do not exist, or generating these breathtaking landscapes. They could even do these wild image translations, like taking a video of a horse and turning it into a zebra. Just wild stuff.
But look, GANs weren't the only game in town. There was another pioneer on the scene taking a totally different approach. Let's talk about the Variational Autoencoder, or VAE.
So, if GANs are all about this cutthroat competition, VAEs are, well, they're kind of the opposite. They're not trying to fool anyone. A VAE's whole job is just to learn. It wants to understand the deep underlying structure of data in a really smart, organized, and probabilistic way.
It does this with a two-part system. First, you have an encoder. It takes an image, looks at it, and basically squishes it down to its absolute essence, just the most important features. Then you have a decoder, which takes that compressed little package of information and tries its best to rebuild the original image from it.
Now, that compressed data the encoder makes, it lives in a place called the latent space. And the absolute best way to picture this is like a map. It's a really detailed, well-organized map where every single point on it corresponds to a specific set of features, like blonde hair, smiling, or wearing sunglasses.
Okay, so how do you create something new with the map? It's actually pretty cool. You can just point to a new spot on the map, a spot that doesn't represent any of the original images. You give those coordinates to the decoder, and it'll look at that point, interpret the features there, and generate a totally new image that makes perfect sense on that map.
And it's this structured map that is the VAE's superpower. It makes them great at generating a huge variety of different images. And they are the absolute masters of interpolation. You know what that is? It's creating those super smooth transitions, like watching one face seamlessly morph into another. They can do that just by taking a slow walk from one point on the map to another.
All right, so you've got the fierce competitor versus the meticulous map maker. Let's put them side by side and really break down the differences.
Yeah, this table really sums it up. The GAN, with its whole adversarial game, is king when it comes to photorealism. The images are just crisp, but that constant fight makes them super hard to train. It's a real balancing act. Now the VAE, with its nice, neat map, is fantastic for getting lots of different results and doing those smooth interpolations. The downside? The images can sometimes come out a little blurry or less sharp. So it's that classic trade-off, You're choosing between realism and diversity.
So when you look back, what's the real legacy of these two? What did they leave us with?
I mean, even though they worked in totally different ways, you can't overstate it. Both GANs and VAEs were absolute game changers. They blew the doors wide open on what we thought was even possible with generative AI.
And that really is the heart of it. They proved for the very first time that you could actually teach a machine something that feels so human, how to create. They demonstrated the feasibility and the power of it all. That was the breakthrough.
And really, everything we see today, all the sophisticated models we use, they were built on the lessons we learned from these two. Think about it. The idea of an organized latent space, that comes from VAEs. The power of adversarial training, pure GANs. The large language models and diffusion models making headlines right now were directly influenced by these concepts. They are literally standing on the shoulders of these two original pioneers.
So yeah, GANs and VAEs were the trailblazers. They were the ones who first mapped out this incredible new territory. And it really makes you wonder, right? If this is the foundation they built for us, what's being dreamed up in a lab right now? What's going to be the next great frontier in machine creativity? It's an exciting thought.